All right, in this section we're going to be looking at solving equations again. This time we're going to be looking at solving equations where we use both principles, and we're also going to throw a couple of goodies in there. So we'll use addition, subtraction principle, multiplication, division principle, and then we'll throw a couple other fun things in there. Again, remember that our total purpose when we're solving equations is we have something up here is equal to something over there with an x in there somewhere. And in the end, we want it to be x is equal to something. That's where we're going. So typically, if you have or if you have an equation in which you've got more than two terms, like this one, like if I had 8x equals 2, then I just have to divide both sides, by 8, and I'll solve that. Or if I have x minus 3 equals 4, then I can add 3 to this side, add 3 to this side, I'm done. So in these ones, I'm just using one principle. Here, where I have a number in front of the x, and I have a couple other terms there, I'm going to have to use more than one principle. So typically what we do, and I'll show you the last step, well maybe I'll go there now. This is typically what we're going to do, is we're going to use the I hate fraction rule, we'll introduce that later, then the distributive property if you need it, then addition subtraction principle to collect like terms, and finally we use the multiplication principle. That's sort of the order that we do it in. Notice if we don't have these top two goodies here, that addition principle is done before the multiplication principle. So in this question here, when I've got 8x minus 4 equals 28, you're automatically maybe thinking, oh, just divide everything by 8. And you could do that if you divide everything by 8. However, it's easier if you first collect all the like terms by using the addition or subtraction principle. So for this particular one, what you would do first is, since I'm subtracting 4, then I would add 4, and that would cancel that out. If I add 4 on this side, I'd have to add 4 on that side. So on the left side, I'd be left with 8x equals whatever 28 plus 4 is. Now I've collected all the x stuff on this side, all the number stuff on this side. Now I can use the multiplication principle. I like to rewrite it, so 8x equals 32. So I'll divide this side by 8, divide this side by 8. 8s are a factor of 1, so they're eliminated, and x is equal to 4. Always in equations, make sure you do a check. And so if I get a 4, that means that 8 times 4 minus 4 equals 28 must be a true statement. So I'm wondering if it's true because I got 4, but I need to check my answer. 8 times 4 is 32. If I take 32 and subtract 4, do I get 38? Sure enough. Therefore, x equals 4 is the right answer. Let's try a couple of these. I'll maybe try this one here and maybe this one down here. Again, I've got multiple terms with a number in front of the variable. I'll use the addition subtraction principle first. So add 2 to both sides. This side I have 3p, this side I'll have 12. Now I'll take each side and divide it by whatever's out front there. Okay, that's our multiplication or division principle. 3's are a factor of 1, they're eliminated. 12 divided by 3 is 4. And then if I do a check, I should maybe put this down a little bit. I'll just toss it up there. I should do a check, so I write my original equation down, and instead of the p, I put what I got for p. Minus 2 equals 10. 3 fourths are 12. Does 12 take away 2 equal 10? If it does, then that means that this is the correct answer. Okay, let's do this one over here. It's a little funny because the order's changed. If I wanted to, I could reverse the order so they're on the same side, so I could just, that's the commutative property, so I could rewrite it as minus 8x minus 4 is equal to 8. I could do that, so this minus is this one, and that minus is that one. So again, let's add 4 to both sides. So I get negative 8x is equal to 12. Notice I didn't lose that negative. You've got to be careful with that. Okay, now I'll divide both sides. So I have negative 8x equals 12. I'll divide this side by negative 8. Divide this one by negative 8. This side, factors of 1, the minuses cancel, so I have an x. And on this side, I have 12 over negative 8, which is negative. If you divide 4 into both of those, I think you get 3 over 2. So that would be the correct answer. And then you should check. Maybe I'll show you the check with this one just because it looks a little nasty. Negative 4 minus 8x equals, what is it? 8. So negative 4 minus 8, and for x, I got negative 3 halves. So I put negative 3 halves right there. Is that equal to 8? That's our question. So negative times a negative, this will be a positive. So the negative 4 out front stays, but this times negative negative is a positive. 8 times 3 is 24, and 24 divided by 2 is 12. Okay, is negative 4 plus 12 equal to 8? I'm down 4, I gain 12. Sure enough, that gives me 8. Therefore, that's a correct answer. Here's some other ones where, how is this one different than the one we did before? Maybe you're noticing that this one has an extra x. If they have x's, really what we're wanting to do, like in this question here, we're wanting to collect these numbers together. So there's a number, there's a number. Let's get them both on the same side of the equal sign and leave the variable alone. In this case here, we have variables here, and I wouldn't want to move this to this side because this and this look the same. They're like terms. So the first thing I'd want to do is add those. So I get 7x is equal to 21. Now I'll use the division principle, divide both sides by 7. I get x is equal to 3. Let's check this one. 4 times 3 plus 3 times 3. Does that give you, oh, that's a negative, I forgot that. Negative, negative. Ooh, my answer would be negative. Darn negatives, eh? Negative. Does that equal negative 21? Negative 4 times negative 3, negative 12, plus 3 times negative 3, that's negative 9. Does that equal a negative 21? Down 12, lose another 9. Sure enough, it does. Correct. Similar kind of question there. Now here's somewhere you've got like lots of y's and lots of numbers. So in these ones, what you're wanting to do is get all the letters on one side and all the numbers on the other side. Typically, people put all the letters on the left side and the numbers on the right, but it doesn't matter. Whichever works for you, they'll come up to the same answer. I'm sort of a left-handed equation solver, so I like my x's or y's on the left, so that's what I'm going to do. First thing I'm going to do is get rid of this 5. I'm going to put that over on that side. So I'll subtract 5 here, subtract 5 there. When I do that, these cancel, so I'm left with a minus 2y equals 3y. Down 5, lose another 5, I'm down 10. Okay, I got my numbers all together, but now this one I want to move over there. So it's a positive 3y, so let's subtract 3y. If I do it there, I've got to subtract 3y here. I'm down 2, I'll lose another 3, so I'd be down 5y is equal to that identity property 0, that cancels, so this will be negative 10. Let me move this equation down a little bit. And now I'll use the division property, so minus 5y equals negative 10. Divide this side by minus 5, divide this side by minus 5. These are factor of 1, they cancel, and I come up with a positive 2. Again, this is something that you should check. I won't just for video purposes, but I think you're getting the idea. This is a real nice one where you have to collect like terms. One thing that hopefully you're noticing so far is that really if you have a positive 3y on this side, it becomes a negative 3y on that side. So you could skip a step if you want and just say, well, here's a 7x, I'll leave that there. There's a positive 2x, I'll leave that. Here's a negative 8x on the other side, so if I move it over to this side, it becomes a positive 8x. See how easily you can get those x's together? Let's do the same thing with the numbers. So far on the right side, I have a 2, I have a plus 15, and then, oh, there's a minus 17 here. If I move it to the other side, add 17, it'll be a positive 17 on this side. So it's just a little quicker getting all your letters and numbers together. Okay, so that'll be 17x is equal to, what's that, 32, 34. And sure enough, if you divide both sides by 17, you come up with x is equal to 2. Again, good idea to check your answer. Okay, let's look at some other goodies here. One of them is that when you are dealing with some fraction or some equations, you might have a fraction in them. And if it's an equation, only if it's an equation, you can use something called the I hate fractions rule. Sort of, I made that up. But what it is, the rule is that if you have fractions, I guess the rule is the multiplication rule. That's all it is. And what it says is if you multiply one thing by a number, you got to multiply everything in the equation by that number. And what you do is you find the lowest common denominator of all your fractions. Here I just have a 2, a 1, and a 1, so lowest common denominator is 2. So then what I do is I multiply every term by that lowest common denominator. In the book they might show it a little different, but for me this is just sort of how it works for me. So I'm going to take this thing and times it by 2, and it'll be like 2 over 1, right? Plus, I'm going to take that 3 over 1 and times it by 2 over 1 is equal to, and I'll take the 1 and I have to times it by 2. There wasn't a fraction there, so I'll just leave it as 2. In this case here, the 2's are a factor of 1, so they're eliminated. So what I get from this is just a negative 1x. Here, 2 times 3 will be a 6, so this is plus 6, is equal to 2 times 1 is 2. Now suddenly I have an equation that looks just like the other ones we've done, with no fractions. Here I've got a 6, I want to move it to the other side, so I'm going to subtract 6 on both sides, and that will leave me with negative 1x is equal to, up to lose 6, I'm down 4, and then I need to use the division principle to get rid of that negative 1, so negative 1x equals negative 4, and I'll divide both sides by negative 1. This side I'll wind up with an x, this side minus 4 divided minus 1, positive 4. Notice how many times you're having to deal with the negative signs. And that's why, like we said earlier, you want to practice that, so it's just automatic. Dividing two negatives, positive. Adding two negatives, they stay a negative, and you add the two numbers. So making sure you know those rules is key. And again, at this point, check. Here's a good one. Maybe pause and try that one, and then come back and see how I've done it. Okay, hopefully you're back. Common denominator of all those numbers, 8. So I'm going to multiply this by 8. I'm going to multiply this by 8. This by 8. And this, oh, there's two things over there. That by 8 and this by 8. In the book, I think that what they do is they just put a big number around the whole thing and put an 8 on the outside. And if you do, that's okay. I guess I'm sort of used to doing it the other way. Okay, so if I multiply this by 8, these two 8's cancel. So I'm left with, is there 7x? 8 times 1 is 8, divided by 4 is 2. So this would be minus 2. Plus 8 times 1 is 8, divided 2 is 4, so that would be 4x. 8 3's are 24, divided 4 is 6, and 8x. Now I've got a question that looks exactly like, oh, not that one, like this one. We've got a bunch of x's on both sides, and I just collect them. So I could have 7x plus 4x. This is on this side of the equal sign, so when it comes over, it's a minus 8x. Here I've got a 6 already. This minus 2, if I add 2, it'll be a positive 2 on this side. Notice I'm skipping some steps there. And skipping steps, no problem with that, as long as you're getting the next step right. If you can do that in your head, perfect. 11 minus 8, this would be 3x, is equal to 8. And then x would be equal to 8 divided by 3. See how I skipped the multiplication or division principle there. Just one quick thing, with decimals you can do the same thing as you did there. It's the same idea. If you can times something, an equation by a certain number to get rid of a pain like decimals, you can. This one you can multiply them all by 10. Times this one by 10, that's 2x. This one by 10, that's 5. This one by 10, that's 7. Suddenly I've got a nice, easy equation to deal with. Okay, one more goodie. Maybe there's two more goodies. The distributive property goodie. If you have frac or parentheses in your equation, you need to get rid of those first. So I guess first get rid of fractions, then get rid of parentheses, and then do your other processes. So this will be, if I multiply the 2 through, I get this, and then subtract 6 from both sides. So you get 4y is equal to 8. Divide both sides by 4. You come up with 2. Make sure you check your answer. Another one, 15x minus 10 equals 35. Add 10 to both sides. So you get 45. Divide both sides by 15. You get 3. Again, you can plug it back in and check. Distributive property. Maybe try one. Try this one. Pause, try this one, and then press play and we'll see how you do. Okay, B21 plus 6x equals 30 plus 7x minus 7. That's 7. Now x's, there's a 6x. Here's 7x. Bring it to the other side, it becomes negative. On this side I have a 30. I have a minus 7. And then here, this 21, if I move it over, becomes a minus 21. Subtract these, that's negative x. 30 take away 7 is 23, and then I lose another 21. So I'm down 2, oh no, I'm up 2. So I'm still up 2. Divide both sides by a negative, you get x is equal to negative 2. See, as I go, I'm sort of skipping a few more steps each time. But hopefully you're getting on to how to do that. If you're not, and if skipping steps bothers you, just put in every step that you can there. And it's a good idea to put in as many steps as you can, just as you're learning, until the stuff comes natural. After that, then you can start skipping some steps. My rule of thumb, though, is if I'm making a mistake, put some more steps in. Okay, so last slide here then. These are the sort of the general procedures for solving equations. Get rid of fractions, get rid of brackets, use the addition principle to collect x's on one side, numbers on the other side, and finish it off with the multiplication or division principle. Try a bunch of these questions. Do as many as you can so that things just become second nature. Okay.